have got a double bond. The double bond is formed through a pi bond and a sigma bond, but you really don't need that for the South African syllabus anymore. They're usually just shown like this, with two single bonds between two carbons. Obviously, since carbon always makes 4 bonds, there needs to be at least 2 other entities attached to each of those carbons. They can be hydrogens, they can be other carbon-hydrogen chains. In the case of it being C2H4, as it is here, that would be ethene. Eth because it's 2 carbons, and then the ENE tells you that it's a double bond. So this structure here you can ignore, but you do need to know that the angles are about 120 degrees. And that it is planar. Now, what I mean by planar is this. I'll show you just using ChemSketch quickly. So when you have an alkene molecule, you have 2 carbons that are bonded. Now, to create that in ChemSketch, you just click and drag again to there. Then you can go and show all your hydrogens. And if you now make this bond, optimize it for 3D, you will see that it is flat. So it is a planar structure. If you look at it from the end, it'll be completely flat, right? The molecule itself, there it's got the double bond, but from the side, it is actually completely planar. That's what we mean when we say it's a planar molecule. All right, so that's ethene. It's the simplest alkene. You can't get a simpler one because obviously you need at least 2 carbons in the molecule. Right, now, what's the structure like? Over here, I've got a bunch of scribbles on this PowerPoint. This is just showing you what happens with the electrons. And on the right here, I've got 2 carbons showing you, and there's this carbon's 4 electrons. This is a Lewis diagram. And this carbon's got his 4 electrons, and obviously each of them just shares 2 with the other one. It's a double covalent bond. So that's the same thing. All right, so let's look through some examples of alkenes. The simplest one, as I said, is ethene. That's there. And then you can show it with a condensed structural formula. To be honest, the double bond is not always shown there. So if you just have a CH2 and a CH2, that would be ethene. Then you've got the next one in the series, and that would be propene. It's got 3 carbons, and it's got a double bond there. Now, you don't need to say prop-1-ene, which would be indicating the position of that double bond, because if you move that double bond to here, it's the same molecule just turned around 360 degrees. So you don't need to show that. You don't need to say it in the molecule. I can show that on ChemSketch. If we delete that and make propene, you can see here you got 1 carbon, 2 carbon, 3 carbons. And if you make that double bond there, and then go and show all your hydrogens, that molecule is the same whether it's that way around or whether it's that way around. So if you move that double bond from here to there, it's basically just the same molecule just been flipped around 360 degrees. So you don't need to say prop-1-ene, you don't need to specify the position of that double bond. So ethene, propene. Now, C4H8 has got 3 possible different structures, right? If you can play with a pen and pencil and draw them, you'll see here you get C4H8. So you've got 1, 2, 3, 4 carbons and 2, 3, 4, 5, 6, 7, 8 hydrogens. So you can have the double bond there, or you can have the double bond in the middle. So now you have to specify, because those are 2 different molecules, where the double bond is. So we would say bute, because that's 4 carbons. Bute-1-ene with the hyphen between the number and the letters, or bute-2-ene. And so the number you're giving is the number of the first carbon in the double bond. Now, if you start from the left here, that's 1, 2. And if you start from the right, it'll also be 1, 2. So it doesn't matter which side you start. That's just giving you the position of that double bond. You can say 2-butene or 1-butene, but the more conventional naming is to put the number in the middle of the name. And then there's another possibility. You could actually move that methyl group from there to here. So it's still 4 carbons, 1, 2, 3, 4, 3 and 3, 6, 7, 8, still C4H8, but now you've got the double bond there. So that's a propene, but it's got a methyl group on the second carbon. So it's methyl propene. Now you don't have to say the position of the double bond, because again, if you move it there, it's the same molecule just flipped around. And you don't have to say where the methyl group is, because it can't be anywhere else. If you move that methyl to here, then you're basically back to the structure. So methyl propene is the other example. Right. So there I've shown those in condensed structural formula. Again, I've shown the double bond. Should really have butane, and methyl propene. All right. So here's a few examples for you to do. So you might want to stop the PowerPoint here and then go and try them yourself on a piece of paper. See if you can draw the structure of these and see if you can name these. I would suggest you draw these out because this is a little bit tricky on these bottom ones. And then once you've drawn them out, then come back and restart the PowerPoint and have a look how you got along. But I'm just going to carry on now, assuming that you've done that. Don't be tempted to short circuit these steps, because trying to do it yourself is far better than just watching me do it. All right, so let's go and have a look. Pent-1-ene. That's the condensed structure. So it's got 5 carbons, 1, 2, 3, 4, 5, and the alkene is just between the first 2 carbons. Hex-3-ene, 1, 2, 3, 4, 5, 6, and the double bond comes after the third carbon, 1, 2, 3. Now I've only drawn the condensed structures here, but I will do the, I think on the next slide I've got the full structures. 2-methyl-1-ene. So the double bond's got to be after the first carbon, and then you've got to have a methyl on the second carbon, and that in the CH3 in brackets is a methyl group. They have drawn out the whole structure, 1, 2, 3, 4, bute, 1-ene with a 2-methyl, 2-methyl bute, 1-ene. And then cyclohexene, just to give you an example of a cyclic compound, 1, 2, 3, 4, 5, 6 carbons with a double bond somewhere, and that would be cyclohexene. So let's go through the naming of these. There we've got pent-2-ene. This is 3-methyl pent-1-ene, 1, 2, 3, 4, 5. And that's your methyl group on the 1, 2, 3, third carbon with a alkene after the first one. And then this one, 2-methyl hex-3-ene, 1, 2, 3, 4, 5, 6 carbons, methyl group on the second one with a double bond after the third carbon, 2-methyl hex-3-ene. You wouldn't start numbering at this side and call it 1, 2, 3, 4, 5 methyl, because you must number it so that the numbers are small as possible. Then this 2,2,4 trimethyl pent-2-ene. Now, if you struggled with that one, let's have a look at it in a bit more detail. It's actually drawn out. For all the others, drawn out nicely using ChemSketch, and here's this very last one. 2, 2, 2, 2, 4. So there's the 2, start numbering the side. 2, 2, 4, trimethyl. 1, 2, 3, 4, 5, pent-3-ene if you start numbering that side. But if you start numbering this side, it would be 2, 4, 4, trimethyl pent-2-ene, and you must give it the alkene as with the smallest number possible. So you must start numbering on the left. So it'd be 2, 4, 4, trimethyl, 1, 2, 3 methyl groups, pent because there's 5 carbons, pent-2-ene. Okay, you must number the alkene as small as possible, with the smallest number possible.